Hey folks, welcome to another episode of Unscripted Coding. Today I have booted up LeetCode again. It's been a little bit since we've done a problem, and since admittedly I'm a little short on time, we're going to do an easy LeetCode problem, and I'm going to walk you through my train of thought. So, we're going to pick one at random. Cool, there's a new page. Oh, that's definitely helpful, being able to drag this along so we can zoom in just a little bit so you guys can read it. So this is problem number 476. It's easy. It's called number complement. The complement of an integer is the integer you get when you flip all the zeros to ones and all the ones to zeros in its binary representation. For example, the integer is 101 in binary, and its complement is 010, which is the integer 2. Given an integer num, return its complement. So, I guess the very first thing you need to do is figure out how to get the binary representation of a number. Admittedly, I don't know how to do that. So I'm going to take out trusty Google here. Python integer to binary. And there might be a function right here. So you can use the bin function to convert a decimal value to its corresponding binary value and switch it back with int. Let's start with that. I am kind of curious how you would do that normally, I suppose. But let's start with this. So you're going to get an input, and it's called num. And so we can get the binary equals bin num. Okay? And let's print binary and see if we can run the test case here. Name is not a valid value for the return type integer. We were supposed to return something. So return binary. Nope. Int binary print. So we're gonna have to return the integer after because we've already created this input output. We've already specified that we're gonna return an output, but you can see from the console that we have we've gotten our print. So we have 101. I'm not sure what 0b is, but I assume that is the a marker that it is in binary. My next question, now that I know this function will run without further installations, is further imports, is we're going to see if we can loop through each of the integers, or each of the digits. So we're going to say for digit in binary, print digit. And we're going to see how that looks here. So 0B101. And I'm not sure why we have returned invalid literal for int with base 10. Let's print our first integer first to see what got put in. Oh, sorry. I was supposed to print num here. Okay, so they started with 5, and we know that it's supposed to be 101. So 0b, we're going to ignore that. And what I'm going to do is we'll put a Boolean up front. And what's going to happen is for digit in binary, it's going to stay false until we hit that letter B. So if digit equals B, then we'll put start equals true. If start, we'll print the digit. This should give us just 101 and no 0B. So 5101, and what we're going to do is replace it. So let's go output binary equals, it's going to be a string. Let's put 0B. Now, when we are starting to see the 1 and 0 and 1, we're going to say if digit equals 0, we're going to add to output binary plus equals 1. So that way it'll flip the digit. If digit equals 1, put binary plus or equal 0. Okay. Now we're gonna print output binary. We're going to turn output binary into an integer. Let's see if that works. Invalid literal for int with base 10. I don't know what that means, but let's Google that up and see. All right, let's go with Code Sculptor just to sculptor. I think I want the Python 3 version. All right, so what we're facing here is just we don't understand how this int to bin works. Int, no, let's go bin. And let's go 0, and let's see what happens. String object can't be interpreted as an index. Okay. Print int. Oh, okay. I'm being... Of course it doesn't make sense. 0B010 doesn't look like it doesn't turn into an integer. So clearly I got this wrong. So let's try this one more time and say how to convert binary string to integer in Python. Okay. Okay, so we can provide the base. So this is the second output. So we don't actually even need this to indicate the base. We just need to provide it as the second parameter for int. So let's run this. And that should work fine. So we'll take out this print, and let's go through our thought process one more time. So first of all, we have an integer that comes in. We're going to use the bin function to turn it into a binary sequence. That was the 0B101. Now the 0b looks like some sort of notification? No, some sort of pretext there. So we only care about the numbers that follow. That's really important because it's a string otherwise. Now we're going to create this output binary, and this is just a placeholder with an empty string. But what we're going to do is loop through each digit in that binary. And why we have this digit b is because we want to get rid of that 0b at the start. So it starts off as false. It doesn't run this section for the first letter. That's a 0. And then when we hit the b, it will ignore this, and because it's a b, it'll flip start to true. And then the following digits will then come into play. And each time we see a 0, we're going to add a 1 to the output binary to flip the digit. And similarly, every time we see a 1, we're going to flip it. We're going to add a 0 to flip it. Finally, we're just returning our output binary turned into an integer at base 2. So I think you kind of need to know your math here, which I really don't. But let's submit and see how we do. Make sure that this is actually working. Excellent. Okay, so this worked just fine. Where I wanted to take a look is how we can calculating binary values, integers into binary math, because I just don't know how to do this. Okay, this is going to help a lot. Understanding radix. Convert binary to decimal. Okay. Okay, I think this one seems to make the most sense. Because it is a base 2, what you're going to do is just keep dividing by 2. And in this case, they start with 13, so you divide it by 2, remainder 1, there's a 1, 6 divided by 2, remainder 0, and then you're going to keep dividing over and over. This is obviously not the most elegant way of doing it, but this one made a lot of sense right off the bat. As soon as I saw it. It's a base 2. You're going to see how many times you fill up that, how many times you fill it up. And because every time you hit 2, you're going to add another digit, you're going to keep dividing, and that will tell you how many digits there are. And I'm saying this all while thinking on the fly, so don't take this as gospel. But that seems to make a lot of sense, and this is a function that we can probably write pretty simply. I don't think it's worth our time to do so, but I hope that was a helpful explanation of how we solved number 476. So thanks for watching. See you guys next time.